Welcome to Stephy's Academy Tuition Center. So today our main focus is a topic in mathematics called coordinate geometry. So we've been given a question here. Find the equation of a straight line passing through points 3,4 and 7,12. So the what's this? The formula we have to use to find we have to first find the gradient. So the formula for the gradient is given by m is equal to y2 minus y1 over x2 minus x1. So we have to label our points there. So we can put this as x1, y1, x2, y2, like that. Then we can replace now. So m is equal to, our y2 is 12 minus 4 over 7 minus 3. So our m will be given by 12 minus 4, that's 8. Then 7 minus 3, that's 4. So 8 divided by 4, that's 2. So that's our gradient. So since we found our gradient now, we have to find the equation of the straight line. So it's given by y minus y1 is equal to mx minus x1. So we can pick the points, either these ones or these ones. So we'll go for this one. So y minus, our y1 is 4. Our gradient, the one we found, 2x minus 3 there. So y minus 4, we multiply the things in the brackets by the 2's. 2 by x, that's 2x. 2 by negative 3, that's minus 6. Then after this, now we can group the like terms together. So y is equal to 2x minus 6. The 4 will cross the equal sign, so it will become plus 4. So y is equal to 2x minus 6 plus 4, that's minus 2. So I'm done, that's my equation there. So following question 1b. Find the equation of a straight line which is perpendicular to the line 2y minus x is equal to 3 and passing through the point negative 4, 1. So we've been given an equation there, 2y minus x is equal to 3. And we know the standard form in which an equation can be put of a straight line is y is equal to mx plus c. So we need to arrange this one into this form. That's when we'll be able to identify our gradient. So 2y is equal to, the x crosses the equal sign there, so it will be x plus 3. Then as you can see, you have the y there. The y is independent. So we divide throughout by 2 over 2 over 2. So y is equal to x over 2 plus 3 over 2. So the 2 and the 2 there, they've cancelled. Yeah. So that's how we've come up with this equation there. So now it's in this form. So now we can pick our gradient. So, okay, you can factorize it further just to make it a bit simpler for you to identify the gradient there. So y is equal to, you can put the half there, then the x can be independent plus 3 over 2. So how we've come up with this, so in front of the x there we had a 1, there we have a 1 there, an invisible one that you are not able to see. So that's how we came up with the half there. So we just factorized there. So now we can pick our gradient now. So as we can see now, our gradient given by that m there. So the m is in front of the x. So our gradient will be equal to half. So now since they've said find the equation of a straight line which is perpendicular, so we have to use this equation. m1 by m2 is equal to negative 1. So we assume this is our m1. So we are finding the m2 there. So now we can, so if two lines are perpendicular, the product of their gradients has to give us a negative 1. So that's why we came up with this equation. So now we can replace. Our m1 is half. So we can put the half there. Half by m2 is equal to negative 1. So it's just the same now as is what we did, the invisible one. So we can just write it as m2 over 2 is equal to negative 1. So m2 equal to, so cross multiply, it's over 1 there. So 2 by negative 1, that's negative 2. 1 by m2, that's m2. So our m2 is negative 1. That's the gradient of the perpendicular line. So we found the gradient and we've been given the points there. So now we can use this formula now. Y minus y1 is equal to mx minus x1. So we are finding the equation of a line. So it has to be in that form. So we are going to use this formula to derive an equation that will be in this form here. So y minus, so we can say this is our x1, this is our y1. So our y1 is 1 is equal to negative 2 x minus our x1 is negative 4. So now we proceed. Y minus y1 is equal to negative 2x. So negative times negative, that's a positive. So plus 4. So this will give us y minus y1 is equal to negative 2 by x, that's negative 2x. Then negative 2 by 4, that's negative 8. So y will be equal to negative 2x. So we'll group the like terms together. So negative 8 there. So the negative 1 will cross the equation and it will become positive. So we group the like terms. So negative 8 plus negative 1 will cross the equation, so it will become positive 1. So y is equal to minus 2x. So negative 8 plus 1, that's negative 7. So yeah, done there. So question 2a. The point P and Q have coordinates 2, 6 and negative 3, negative 6 respectively. Find the distance between point P and Q. You can assume this is our point P and this is our point Q. So we are finding the distance there. So our point P, they've given us the points 2, 6, and for Q, negative 3, negative 6. So the formula we use to find the distance is given by distance is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So distance is equal to the root of, so you can label the points now. So this will be your x1, this will be your y1, this will be your x2, and this will be your y2 there. So we replace now. Our x2 is negative 3 minus our x1, that's 2, we square plus our y2, that's negative 6 minus our y1, that's 6 squared. So distance will be equal to the root of, so negative 3 minus 2, that's negative 5. So negative 5 squared plus negative 6 minus 6, that's negative 12. Negative 12 squared. So distance will be equal to the root of, so negative 5 squared, that's like negative 5 times negative 5. So that has to give us a positive. So that will be positive 25 there. Plus. So negative 12 squared as well, it's negative 12 by negative 12. So that's 144. So distance is equal to the root of, so 25 plus 144, that's 169. So distance is given by the square root of 169, that's 13, and you also put units there. You're done. Okay. The diagram below shows two lines L and N that are perpendicular to each other. The equation of line N is 3x plus 2y is equal to 6. The line L passes through the point 5, 4. So they want us to find out. So our diagram is that there. So that's our diagram there. So we have line L and line N. So find the equation of line L. So we've been given an equation here of line N, which is 3x plus 2y is equal to 6. So I can just write there 3x plus 2y is equal to 6. Yeah. So that's our equation for line N. So like I said, equation of a straight line, we need to have it in this form in order to find the gradient. As we can see, line N and line A are perpendicular to each other. So our line N is 3x plus 2y is equal to 6. So it needs to be in this form. Y is equal to mx plus c. So 2y is equal to 6. So the 3x has to cross the equal sign there, so it will become negative 3x. So you can just write it properly there, negative 3x plus 6. So we divide throughout by 2. So over 2, over 2, over 2. So the 2 and the 2 they cancel. So we have y is equal to minus 3x over 2, then plus 2 into 6, that's 3. So now we can get our gradient there. So as we can see, our gradient, our m in front of the x is negative 3 over 2. So m is equal to negative 3 over 2. So now, since we have our gradient now and we can see line N and line A are perpendicular to each other. So we use this formula again, m1 times m2 is equal to negative 1, because when we multiply the two gradients that are perpendicular to each other, we get a negative 1. So assume this is our m1. So we can replace there in the equation. So negative 3 over 2, m2 is equal to negative 1. So our m2 there is over 1. So we multiply the 2. So negative 3 by m2, that's negative 3 m2. Then 2 by 1, that's 2. So over 2 is equal to negative 1. So now we can cross multiply there. So this is also over 1 there. So 2 by negative 1, that's negative 2. Then 1 by negative 3m2, that's negative 3m2. Then we divide throughout by negative 3 over negative 3. Negative 3 and negative 3 disappear there. So our m2 will be given by negative 2 over negative 3. So the negative and the negative will go. So we'll have 2 over 3. So that's our m2. Then now we have to find our equation. Since we've been given the points there and we've come up with our gradient. So this will be our x1, y1. So use this equation, y minus y1 is equal to, so since we found our gradient here, our m2 is 2 over 3. So now we have to find the equation of line L. So you can use this equation to come up with the equation there, y minus y1 is equal to mx minus x1. So y minus our y1 there is 4. Our when we found our m2, that's 2 over 3 x minus 5. So so this will be, so let's just cross multiply here. Yeah, so this is over, okay, so what we'll do here, so we know this is over 9, even this is over 1. So first let's deal with this part here. So y minus 4 over 1, leave it like that. So 2 by x, that's 2x. 2 by negative 5, that's negative 10, over 3 by 1, that's 3 there. So now we can cross multiply. So 3 by y, that's 3y. 3 by negative 4, that's negative 12 is equal to 1 by everything. It's the same. So 2x minus 10. So now we have 3y, we group the like terms together. 3y is equal to 2x minus 10, and the negative 12 will cross the equal sign to become plus 12. So 3y is equal to 2x, negative 10 plus 12, that's 2 there. So we are done. That's the equation for line L. So the points A and B, so our question 3A, yeah, it's the one we started. So the points A and B are negative 5, 15 and 3w, comma w, respectively. Given that the midpoint of the straight line joining A and B is 5, 10, find the value of w. So the formula for the midpoint is given by midpoint, can write it, is equal to, so this will be x1 plus x2 over 2, comma y1 plus y2 over 2. So our midpoint they've given us is 5, 10. And then the values there, so we can label the values there. So this is our x1, this is our y1, and this is our x2, and this is our y2. So we are finding the value of w there. So we can replace. So our midpoint values are 5, 10 there. Is equal to our x1 is given by -5 plus our x2 is given by 3w over 2, comma our y1 is given by 15, our y2 is given by w over 2. So now what we'll do, we can separate these values here the way they are. So as we can see, this is x, this is also x, this is y, and this is also y. So so as you can see, the value of x there and y. So you can equate these values. The value of x equal to the value of x. The value of y equal to the value of y, because we are finding same value of w. So for me, I'll deal with this value, but I'll also elaborate on how you can do it using the value of x. So 15 plus w over 2 is equal to, the value of y is 10. So this is, you can say y there, we're dealing with y. So if you want to deal with x there, you can say -5 plus 3w over 2 is equal to 5. So we know this is over 1, so we can cross multiply there. So 15 plus w by 1 gives us 15 plus w is equal to 2 by 10, that's 20. So we group the like terms together, so it will be w is equal to 20 minus 15. So w is equal to 5. So we can now use the value of x as well. Or if you want, you can use the value of x there. So we can say or, yeah, because we're just coming up with the same thing. Yeah, but in the exam, just go with 1 because you have the same value there. So you'll be just wasting your time. So this is also over 1 there. So we cross multiply. 1 by -5 plus 3y, we get the same thing there. Or 3w, sorry. Is equal to 2 by 5, that's 10. So 3w is equal to, the like terms together, 10, the 5 crosses the equal sign, it becomes plus 5. 3w is equal to 15 over 3 over 3. So w is equal to 3 and 3 go there. 3 into 15, that's 5. See, still getting the same thing there. Yeah. So question 4a. Given that the lines 3y is equal to x plus 6 and y is equal to kx plus 12 are perpendicular, find the value of k. So guys, these lines are perpendicular, so meaning they are making a 90 degree there. So you can use this equation here to come up with the value of k there. So we'll get this equation, 3y is equal to x plus 6. So it has to be in this form. Y is equal to mx plus c. So 3y is equal to x plus 6. So over 3 over 3 over 3. So the 3 and 3 will go. So y will be equal to x over 3 plus the 3 into 6 there, because there are 2 times. So now we have our gradient for this line here. So our m, we can just say our m1 is equal to So this will be 1 over 3 because there's an invisible one there in front of x there. So since they've said these two lines are perpendicular to each other, so we'll come up with, or we'll use this equation to find the gradient of m2, which is our k, because the lines are perpendicular. So we'll say m1 times m2 is equal to -1. So our m1 we found it to be 1 over 3 times m2. So you can say this then is equal to -1. So we multiply these two first over 1. So by 1 times m2 gives us m2 over 3 times 1, that's 3 is equal to -1. So this is also over 1. So we cross multiply. So 1 by m2 is m2. And 3 by -1, that's -3. So we found our gradient for this line, a line 2. So we can just say k is equal to -3 because the two lines were perpendicular. So meaning the gradient for this one is perpendicular to that one. So that's how. So question 4b. A straight line L has equation 3y is equal to 5x minus 6. Find the y coordinate of the point where L cuts the y-axis. So guys, what you have to know is, in the y-axis, x is equal to 0. Then in the x-axis, y is equal to 0. So here they've told us to find the y coordinate of the point where L cuts the y-axis. So meaning x is equal to 0. So 3y, we get our equation, is equal to 5x minus 6. So where there is x there, since they've said in the y-axis, so where there is x, we put a 0 there. So it will be 3y is equal to 5, and we replace there with 0 minus 6. So we have 3y is equal to 5 times 0, that's a 0. So we can just say minus 6 there. Yeah, or 0 minus 6. So 3y is equal to 0 minus 6, that's a -6. Then we can divide throughout by 3 over 3. So we cancel. So y is equal to -6 over 3, that's a -2. So we are done since they've said the y coordinate. So they didn't say the coordinate, so they just said the y coordinate. So you are done right there. So question 5a. A and B are points with coordinates -3, and 5, 9 respectively. Find the length of AB. So length is just the same as distance. So we can say length of AB is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So we can label our points here. So this will be our x1, this will be our y1, this will be our x2, this will be our y2. So is equal to, we can start replacing now. Square root of our x2 is 5 minus our x1 is brackets -3, then we square plus our y2 is 9 minus our y1 is 3 squared. So length AB there is equal to the root of, so 5, so first negative times negative. So we can have 5 there, negative times negative, that's positive. 3 squared plus, for this one, let's do it in advance. So 9 minus 3, that's 6. And so we have 6 squared. So AB is equal to the root of, so 5 plus 3, that's 9. 9 squared plus 6 squared. So this will be equal to AB is equal to the root of, so 5 plus 3, that's 8. Sorry guys, yeah, it's 8. Yeah. So 8 squared, that's 64. 64 plus 6 squared, that's 36. So AB is equal to 64 plus 36, that's 100. So AB is equal to the root of 100, that's 10 units there. We're done. So in the diagram below, A is the point 0, 4, that's our point A there, and B is the point 2, 0, and 0 is the origin there. Yeah. So the question is, find the equation of a straight line through point 0 there, which is parallel to the line AB. So meaning I can say, so our line is here, guys. So first what we have to do, we have to first find the gradient of the point AB. So we can find that time. So M is equal to y2 minus y1 over x2 minus x1. We can label this as our x1, y1, x2, y2, and you can replace there. So M is equal to y2 is 0 minus y1, that's 4, over our x2 is 2, our x1 is 0. So M is equal to negative 4. 2 minus 0, that's 2. So M is equal to negative 4 divided by 2, that's negative 2. So the gradient here is, you can say M is negative 2. So even here the gradient is negative 2. So the gradients are the same. So it's because the two lines that are parallel to each other have the same gradient. So since we found the gradient there and we have the point here, the origin, so the points on the origin are 0, 0 there. So we have our gradient. So I have our gradient, M is equal to negative 2, and the points of the origin are 0, 0. So we can use now the equation to come up with the equation. So y minus y1 is equal to mx minus x1. So y minus, say x1, y1 there. Our y1 is 0. Then our gradient, negative 2. Our x and down minus x1, 0 there. So y minus 0, that's y is equal to negative 2 times x, that's negative 2x. Negative 2 times 0, that's 0. So that's our equation. 6a. Find the gradient of a line which passes through 1, 5 and 2, 10. So I'm just finding the gradient. So here's the formula. M is equal to y2 minus y1 over x2 minus x1. So our M is equal to, so we can label our parts there, x1, y1, x2, y2. So our y2 is 10 minus our y1 is 5. Our x2 is 2. Our x1 is 1. So our M is equal to 10 minus 5, that's 5, over 2 minus 1, that's 1. So M is equal to 1 into 5, that's 5. So that's our gradient. Then we can proceed to B6b. The equation of the line A is 3x plus 2y is equal to 10. Line B is parallel to the line A and passes through the point 4, 6. Find the equation of the line B. So line A and line B are parallel to each other, so meaning they have the same gradient. So we can use the equation for line A to come up with the gradient. So the equation is 3x plus 2y is equal to 10. So it has to be in this form. Y is equal to mx plus c. So we can arrange this. So 2y is equal to 10, then the 3x crosses the equal sign, it becomes negative 3x. So I have 2y is equal to negative 3x plus 10. So we divide throughout by 2. Over 2, over 2, over 2. So our y, the 2 and the 2 goes there. So y is equal to negative 3x over 2 plus 2 into 10, that's 5, right? So now we have our m there, our gradient. So our gradient is negative 3 over 2. So now we have to find now the equation of line B, because they are what? Parallel to each other. So they have the same gradient. So we just use this equation, y minus y1 is equal to mx minus x1. So we can label this as x1, y1, and our gradient is the same. So y minus our y1 is what? 6. Our m is negative 3 over 2. X minus 4. So we have y minus 6. So this is over 1. So multiply this. So negative 3 by x, that's negative 3x. Negative 3 by negative 4, that's positive 12. Over 2 times 1, that's 2. So this will be, so now we can cross multiply. So this is also over 1. So times 2 times y, that's 2y. 2 times negative 6, that's negative 12. Is equal to 1 by everything there, get the same thing, 3x plus 12. So we group the like terms together now. So 2y is equal to minus 3x plus 12, then the negative 12 crosses the equal sign and becomes positive 12. So 2y is equal to minus 3x, 12 plus 12, that's plus 24. So that's our equation for line B. So question 7. Find the equation of a straight line passing through 1, 5 and 2, 10. So first what we'll do, we'll find our gradient. So m is equal to y2 minus y1 over x2 minus x1. So we can label our parts now. There are points. This will be x1, y1, x2, y2. Then we can replace. So m is equal to y2 is 10 minus y1 is 5. x2 is 2 minus x1, that's 1. So m will be equal to 10 minus 5, that's 5, over 2 minus 1, that's 1. So m is equal to 1 into 5, that's 5. So we have our gradient. So we can either use this point or this point to come up with our equation. So let's go for this point. So y minus y1 is equal to m x minus x1. So y minus our y1 is 5. Our gradient is 5 as well. X minus our x1 is 1. So we have y minus 5 is equal to 5 by x, that's 5x. 5 times negative 1, that's negative 5. So y is equal to 5x, group the like terms, minus 5. This one crosses the equal sign, so it becomes plus 5. So y is equal to 5x. That's our equation there. So negative 5 plus 5, our answer is 0. So this has disappeared. So we can't put a 0 there. Yeah, it's always there. Yeah. So our question 8 reads, the gradient of the line joining the points negative 2, k and k, negative 14 is 2. Calculate the value of k. So they've given us our gradient to be, our m is 2. And they've given us 2 points there, negative 2, k and k, negative 14. So they want the value of k. So we can use this formula. M is equal to y2 minus y1 over x2 minus x1. Then we can label this to be our x1, this is our y1, x2, y2. So our m we just replace there is 2. Our y2 is negative 14. Our y1 is minus k there over our x2 is k, then our x1 is negative 2. So 2 is equal to negative 14 minus k over negative times negative, that's positive, right? So k plus 2. Then this is over 1. Now we can cross multiply. So 2 times this, k plus 2. So 2 by k, that's 2k. Then 2 by 2, that's 4, is equal to 1 times everything there at the same thing there, negative 4 plus k. Now we can group the like terms together. So k cross the equal sign to come here under the positive 4 cross the equal. So the k first can write 2k, negative k crosses the equal sign becomes positive k is equal to minus 14. Then positive 4 crosses the equal sign becomes negative 4. So 2k plus k, that's 3k is equal to negative 14 minus 4, that's negative 18. So we divide 3 there over 3. 3, 3, go. So k is equal to 3 into negative 18, that's minus 6. Done there.